Okay, so I want to solve this inequality using the same kind of steps that we use for equations. Only thing that changes is the inequality symbol. Here we have a greater than or equal to, and the only time that symbol will change is if you divide or multiply by a negative at any point over the sign. We'll see if we use it, but first we want to actually solve this for what we have. All right. I look first, there is no distributive property. I don't see any parentheses. I'm looking at both sides of the inequality. I don't see any like terms. So I am going to go to that next step, which is to solve the two-step equation. So first, I am going to write the problem. That's 2x greater than or equal to 14. All right, so now what I want to do is I'm isolating the x. So I'm going to remove the constant first. That's this positive 8. So I'm going to subtract that on both sides. Here I have negative 2x is greater than or equal to 14 minus 8, which is 6. Then I'm going to divide to get that x alone. I am dividing by a negative 2. All right, and as soon as you divide or multiply by a negative across the sign, that is when you flip it. So in our answer, we won't have a greater than or equal to. We will have a less than or equal to. All right, so these cancel. There's my x. And 6 divided by negative 2 is negative 3. There is my solution. All right, and always check it, plug it a number in that works. A number less than or equal to negative 3, let's say, is negative 5. If we plug it in, 8 minus 2 times negative 5 is greater than or equal to 14. And let's just check if it's true. So 8 minus 2 times negative 5 is greater than or equal to 14. So let's see. We have 2 times negative 5, which is positive 10. So 8 plus 10 is greater than or equal to 14. Simplify this. You have 18 is greater than or equal to 14. And this is true, all right? 18 is greater than or equal to 14. It checks out. That means our solution checks out. All right, that's just one example. Let's go to another one. All right, so this one here, we do have distributive property, same idea. So I want to get rid of that first. I am distributing 4 times x is 4x. 4 times negative 3 is negative 12, less than 8. All right, now here we did the distributive property. I look at both sides separately, both sides of the symbol. The left side has no like terms, the right side has no like terms, so that means we can start solving our two-step equation. All right, get that constant. We're adding 12 on both sides. Here I have 4x. These cancel. 18 plus 12 is 20. Divide by 4. X is less than 5. All right, and notice we did not divide or multiply by a negative, so the symbol stays the same. We do not flip it. All right, one more. Here, I'm going to see that there's distributive property on both sides. So I do negative 3 times x, negative 3x, negative 3 times 8, negative 24. That's on that side. Let me put the symbol. 2 times x is 2x. 2 times 3 is positive 6. All right, make sure we use those signs. All right, that's how we got this negative 24, for example, negative 3 times positive 8. Just make sure you pay attention to those signs. All right, so now distributive property is done. I'm looking at both sides. I do not see any like terms on the left or the right. So that tells me I have to get next the variable on one side because it's on both sides. So I'm going to make this easier for myself and try to keep them positive. So I'm going to add this 3x, the opposite of minus, adding 3x on both sides. These cancel. Here I have negative 24 is greater than or equal to 5x plus 6. All right. I'm going to subtract my constant. This is that two-step equation. This cancels. I have negative 30. If you're unsure of your negatives, just use a calculator. Nothing wrong with that. Then I'm dividing by positive 5 to get x alone. And I'm left with x on the right side. And this is going to be the greater than or equal to symbol. And that is negative 6. All right. Most of the time, we always have that variable on the right. So if you flip this, if you say or, you could say x, and just make sure that small side is still pointing toward your x. Negative 6. All right. So either one of these is the same, as long as the I guess the arrow, if you want to call it, is facing towards your x. All right. This still means the same if you flip them. All right. So I just want to give you guys some examples of it. Flip through this, rewind it if you need to help you with any solving you are going to do in your problems.